Welcome back to one of our last review videos on research methods and statistics. I'm going to go through this kind of quick. Remember, our goal is to prime you. You should have your review packet open to this section so you can kind of follow along on your page, even though I'll have it up on the screen for you. We're going to go through fairly quickly. You can always go back and review or send me any questions that you have. So let's take a look quick. First here, we're going to talk about scales of measurement, and these are just different ways numbers can be used to tell a story, and that's what statistics does. It's a numerical storytelling method. These scales are different types of numbers. So a nominal scale is just a naming scale. This is when numbers just represent an object, like a uniform number. And it categorizes things. So you can't do any meaningful comparison with the numbers. Like numbers on jerseys, you can't do meaningful comparisons on them. Ordinal scale, this is just when numbers are used to represent order of finish. For example, in a cross-country race, numbers 1, 2, 3, 4 finish 5th, 6th, 7th, 8th, but it doesn't tell you how much better the first runner is than the 7th runner. An interval scale, you can do some comparisons because there's an equidistant between each data point. But since there's no true zero in the scale, you can't do a lot of meaningful comparison. You can't say 10 is twice as much as 5. Most psychological tests are interval scales because there's no absolute zero. So on a personality test or an IQ test, for example. So you can't say somebody with 140 IQ is twice as smart as somebody with a 70 IQ. A ratio scale is the most powerful one. That's the last one down here. There is equidistant between data points, and it has an absolute zero. We're pretty familiar with a lot of these measurement devices like weight or time or distance are the most common ones. And there is an absolute zero, so you can say that 10 feet is twice as far as 5 feet, or 10 pounds is twice as much weight as 5 pounds. Okay. Another way we can use numbers is to measure central tendency or measures of the middle. So central tendency is the middle in a set of data. So we're talking about a set of data, a set of test scores, for example. And there's really 3, and you might be asked about these. My guess is you'd be asked about the median, or the mean, excuse me. But this test is going to be different, so I'm not sure. The mean is the arithmetic average, the statistical average. So you add up the numbers and divide by the number of data points that you have. So if you have 6 twos, you'd add those up to be 12, then you divide it by 6. The median is the middle point in a set of data. So you put all the numbers from lowest to highest and then find the middle number. So if there's an odd set of number points, then there's going to be one single middle number. If there's an even set of data points, you take the 2 middle numbers, add them together and divide by 2. The mode is the most, and there's one mean and there's one median. The mode, there can be more than one mode, and there doesn't have to be a mode, but the mode is the most commonly occurring score. Remember, the mean is the most powerful because it takes every data point into consideration, but it's also the most susceptible to deviation because of extreme scores. So if you have a small group of scores in the middle, and then there's one outlier on a quiz, a bunch of people had a 10-point quiz, everybody in class got a 4 or 5, and then the one person out there got a 10, that's going to pull the average towards the 10. Measures of variation is measures of difference. This tells you how much dispersion or variation there is in a set of scores. So just knowing the measure of central tendency is not as meaningful if you have the middle score measure of central tendency and how much variability there was in the scores. Less variability, the more reliable the set of scores is. More variation or variance means that the scores are less reliable. Range is the most common. It's down and dirty. It only takes 2 measures into consideration, the highest and the lowest. Subtract the lowest from the highest. So if you have IQ scores and the lowest is a 90 and the highest is a 120, Subtract 90 from 120 and you have a range of 30. You're not going to get reference to variance here, but you might get reference to standard deviation, standard difference, the average difference. You're not going to have to calculate it, but do know what it means. It means how much each number typically differs from the mean. So if you have a standard deviation of 8, that means each number typically varies from each other by 8 points. It's important to know on an IQ test that the standard deviation is 15 on a standard IQ test. That means, well, we'll get to that when we get to our normal distribution. But the range here is affected most by outliers. The mean is affected most by outliers or measures of central tendency. Distribution of scores. You're going to have an FRQ on statistics and experimental design. Expect some sort of graph or chart. This is likely to be a normal curve or a normal distribution, so you have to know a lot about that. Sometimes referred to as a bell curve. It is a distribution of scores, and a normal curve means the 50th percentile, the middle of the set of scores. The mean, the median, and mode are all the same number. So 2 pages down in your packet, you have a normal distribution with this data. I would look at that right now, turn it horizontally. I'm going to move up here to this smaller version. And we're going to talk about this. So if you imagine a set of scores, the x-axis has the score, the y-axis has the frequency. So this is a normal frequency distribution. And then we would plot all the scores. And if we have a large enough sample on a standardized test, we would expect the scores to follow this normal curve. The top of each set of data points would create this this bell distribution. Now, what do we have to know about this? We have to know the middle, right? That's the mode, so we can easily see the most common score. But we're also going to see that this is a mirror image of each other, that there's a 50th percentile in the middle. And on an IQ test, the score is going to be 100. So the average IQ is 100. The standard deviation allows us to make meaningful comparisons of people's scores. Are you 1 standard deviation above? And that's 15 points on a IQ score. And you're going to see that down here on your graph, right? We have 100 here is the average IQ score. And if you go 1 standard deviation above, you're going to increase by 15. 2 standard deviations above, you're going to increase by another 15. So you're going to go from 100 to 115 and 130. What's important to know is the standard deviation is 15. You go down or up, you're going to add 15 to each score or subtract 15 from each score. And it's important to know because we can easily figure out your percentile if we know how many standard deviations you are above or below this, okay? So here's some numbers you're going to have to know. If you look at this graph and you see 1 standard deviation above, that's a score of 115 because we added 15 to 100. If you subtract 15, you're going to get 85. That's the biggest percentage of people scored in this range. That's where most of the data points are. You have to know this number, 65% of all people who take a standardized test score between 1 standard deviation below and 1 standard deviation above. Remember, you don't have to worry about calculating it, but you have to know that number, 68%. 68% score in here. Now, if you go 2 standard deviations above and below, that would be 115, 130, 85, 70. Look at that. That's a big, huge percentage of the population who took that test. That's a 95%. We're going to round here because we don't get a calculator. 95% of the population scores 2 standard deviations above and below. And if we go 3 standard deviations above and below, so that would be a score of 145 or 55 down here, that's 99% of the whole population that took that scores in that range. Now, it's important to know, you might get asked, if you scored 1 standard deviation below the mean, which is 100, on an IQ test, what is your percentile, okay? I'm going to give you a down and dirty way to figure that out. You always start in the middle, that's 50th percentile, and you simply add or subtract half the standard deviation range. Remember, the range is 68, 95, and 99. So if I said one standard deviation below the mean, I'm going to go down here. I'm going to start at 50. I'm going to subtract half of 68, because I'm only talking about this range, which would be 34, right? Half of 68 is 34. So I go down here, I subtract from 50 if I'm going down this way, I add to 50 if I'm going this way. So I'm one standard deviation below. I take half the range of one standard deviation, which is half of 68 is 34, and I subtract that from 50. That gives me 16. I'm at the 16th percentile here, okay? 16% scored below, 84% scored above. What if I was one standard deviation above? Now I'm up here. Well, half of that range, one standard deviation is 34. If I'm above it, I add 34 to 50. That gives me 84. My percentile is 84%. 84% scored below, and it looks like 84%, right? Only 16% scored above me. So remember, you just find the range, 1, 2, or 3 standard deviations, 68, 95, 99, and add or subtract half to whatever, to 50. Add or subtract half that range and add it or subtract it to 50. Now, skewed distributions. What if you have a smaller range? This could be test scores in a class. A skewed, stats people, you'd say skewed left. This would be skewed to the left. This would be skewed to the right. In AP Psych, I just totally reversed that. We're skewed right here because that's where the lone high score is, and we're skewed to the left here. The skew is where the outlier is. Here we'd say positively skewed because the number's a positive high number out here. Negatively skewed if it's below. And where would the mean, median, and mode be here if we had lines here, like the mean, median, and mode? The mode is easy. It's the blowhole. Remember I talked about the tail of the whale? And if we drew an eye here and a blowhole here, that would be the mode. The tail of the whale would be out here, and the mean is pulled farthest to the tail of the whale. So the mode would be here, the tail mean would be here, and what's in the middle? The median. So it's mode, median, mean. Mode, median, mean. Most of the scores here, outliers out here, okay? Now you might get a bar graph, you might get a histogram. A bar graph is, you'll recognize it right away because the bars are not touching. This is how we graph categorical data. Frequency on the y-axis, frequency on the y-axis. With a bar graph, it's categorical. It's flavors of donuts. It's car makers. It is classes taken in college. So they're categories, and we're just saying how many people did each of those. How many people took East Asia tradition? How many people took Russian history? How many people took economics? So just frequency. Histograms usually have continuous data. You'll see the bars tend to be connected. Down here we have some continuous measurement. It's going to tend to be a ratio schedule or ratio scale. It doesn't have to be, but this might be weight, 90 pounds, 120, 150, 180, 210, 240. And it gives you a range of people. This could be 5, 10, 15, 20. So here we'd have 5 people between 90 and 120 pounds here. They could all 5 be at 90 pounds, they could all 5 be 120, or they could all be in the middle somewhere, but we're doing ranges of scores here, and this is continuous data, weight, time, distance, okay? And the frequency would be listed on the side here. We're going to continue here a little bit. We talked about scatter plots in a previous video, but scatter plots represent correlations, and they're the connecting dots between 2 variables. This could be hours spent on social media and GPA, okay? Or minutes spent on social media per day and your GPA. So correlation coefficient, right, represents that number. -1 is a perfect negative correlation, +1 a perfect positive correlation. Negative means they vary in opposite directions, and you're going to see numbers go down from left to right on a scatter plot. Positive numbers would go up from left to right on a scatter plot. The tighter the dots are, stronger the correlation. Here's a strong negative correlation. If they're in a perfect row, that's a perfect correlation. That'd be +1. Here you probably have a 0.75 or a 0.8 correlation. It's pretty strong. But the numbers are dispersed a little bit, but it's negative because it goes down from left to right. So that's how to, and remember, if you have to put your measurements on a scale and you have to make a graph, the numbers that are in question, like how many hours do you spend on social media, that goes on the x-axis. The one that you don't change is the GPA. So you can easily change the hours you watch or spend on social media. Statistical significance. Statistical significance means that the data that you found, the difference you found between your experimental group average and your control group average was not likely due to chance. It doesn't mean a big difference. It means that we used a powerful inferential statistics test, probably a t-test, to see what was the likelihood that that difference you found between the two groups, their averages, isn't likely due to chance. That's referred to as the p-value, okay? The p-value, just remember, is the probability value, the probability of that score happening by chance. And if it's 0.05 or smaller, then we'll say the data is statistically significant. You don't have to calculate it. You just have to know if the number is smaller than 0.05. And 0.05 means a 5% chance that the data was random and the data didn't get caused by the independent variable. Then we'll say something is statistically significant. So if this is 0.067, it's not statistically significant because it's got to be smaller than 0.05 or 0.05 or smaller. If the p-value is 0.04, it's statistically significant. There's only a 4% chance that the data we ended up with is random or error, okay? The alpha level is what we established at the beginning of our research, and the alpha level is the important numerical level of our tolerance for error. And we set that at 5% in behavioral sciences. It's got to be tighter in the medical field or pharmaceuticals, okay? So if the p-value is smaller than the alpha level, which we set first, there is statistical significance. So just remember this, statistical significance does not mean big difference. It means any difference that we found between the mean of the experimental group and the mean of the control group is not likely due to error or chance. Now, a type 1 error, you want to reject your null hypothesis, right? And I don't think I talked about the null in my other video. It's the hypothesis that we assume true unless we find a difference. So the null hypothesis would be there is no difference. There will be no difference. Or that the IV will not affect the DV. Okay, the IV will have no effect on the DV. We want there to be a difference. So the type 1 error is, let's say we find a difference and we find a statistically significant difference between the experimental control group. So we reject the null. We found a difference. That's the first type of error we can make. So just think we want to reject the null. If we do, that's the first type of error we can make. A type 2 error is we failed to reject the null. We didn't find a statistically significant difference. So the p-value is bigger than the alpha. But we should have, so there was some type of error in our research. Reliability just means repeatability. Validity means the test measures what it's supposed to measure. Or external validity means we can take the information we found out about our subjects and generalize it to the population. So from the sample to the population. So internal validity is the test measures what it's supposed to measure. So, if I give you an AP Psych test on experimental methods, but 90 of the 100 questions was about stats. It wouldn't have internal validity. It doesn't really measure your knowledge about experimental methods. External predictive validity means you can generalize to the population. And the criterion is just the behavior that we're testing, IQ, for example. Standardization, that's when we can meaningfully compare your score to a baseline sample of people who already took that test. And we gave enough questions to end up with a bell curve. So if we were skewed right, think about what that looks like. That means there were only very few high scores and a lot of low scores. We'd take out some difficult questions and put in some easier questions and move that mean to the middle 50 percentile. And that means then we can compare your score meaningfully. So the AP test normally is standardized against people who finished introductory to psychology in college. So that's it. We're going to stop there and send questions.